Okay, today we're going to move on. We're going to go ahead and go into dividing. We're going to talk today, first off, on estimating, and then we're going to actually do what we call the division algorithm. We're going to start with a couple easy things just to get your minds back into division and understanding what we're doing. So our first one is set up quite simply. And I'm going to go ahead and do these in fraction form initially, because when we're doing estimating, that's a really good way to think of this. So if I'm going to do this one, I'm dividing 150 by 30. I think when we do it this way, it helps you guys see with those quick reductions, right? So what can I divide those both by? 10. So really, you just cross out the zeros, right? It's 3 and 15. So our times of 3 go into 15.
5.
So what does that equal? 5. Pretty easy, right? When we're estimating, this is really what we're trying to do. We're trying to get two numbers that go together really well so we can actually do the math mentally. Now, what you just heard me say is something I don't like to say, because as a mathematician, I don't want you doing math mentally. I want to see your work. And this is why I have historically really not liked doing estimation, same as Miss McShann. Okay? Because I prefer to have an exact answer. So I'm going to share a quick story with you guys. This changed for me about 4 years ago. I was teaching at Lodgeville Elementary, and our 8th grade math teacher was phenomenal. She's like a serious mathematician. She makes me look like I don't even know what I'm doing. So when I was doing this lesson, I was asking her, I'm like, you know, I don't like teaching estimation. How do you do this? Do you do this? She was like, you know, I'll be honest, I used to never teach estimation because I'm with you. I want the cold hard facts. I want to see what the answer is. She said, where I changed my mind was I was at the BX, and two of our fellow teachers were at the BX. She didn't give me their names, but she said I saw them, and they were in the infant section because one was buying a outfit for their grandchild. And the outfit was on sale. And the one teacher said, oh, wow, it's on sale. What a great sale. How much is it going to cost? And the other teacher looked back at her. She's like, I don't know. I always just let it figure it out when they ring it up at the register. Couple big problems. Number one, estimation isn't hard if you practice it. Number two, are the registers always accurate? No. There's actually a lot of times they're off, especially when they're doing sales. So if I go to the register and I don't actually know how much I should be paying, I could end up paying a lot more than I should because I didn't notice that they didn't take off the sale properly. So is estimation good? It is, but realize it's not overly accurate. We're really just basically looking to get to the same place value, but it will at least get you in the ballpark of where you should be. So if I go to the register and I'm buying a TV that's a $1,000 TV on sale for 25% off, and they ring it up at $900, did they ring it up right? No, it should be around $750, right? But regardless of what the numbers are, I should be able to do quick estimation so I at least know I'm in the ballpark. And that's really what the focus on the initial part of our lesson today is being to understand how to do those quick estimations, get the numbers so they're easy for us to use in our heads so that we can do this math mentally. Okay? So we're going to do our first one, 2,970, we're dividing by 11. Now when I'm going to estimate, guys, the first number I really want to look at is my divisor. What am I dividing by? Because that's going to help me understand what I need to round the other piece of the number to. So 11 should be probably rounded down to 10. Now because it's a 10, that's going to make it super easy. I can basically make the first number anything I want to. So 2,970, what do you think I should round that to? 3,000. Keeping would work with a 10, but we're going to go ahead and round both just to get nice even numbers. So I'm going to go 3,000 divided by 10. Since I'm taking off 10, all I'm doing is taking off the 1 0, so that's going to be 300. Okay? So now one thing they want us to do today, use a calculator to actually find it, and then we can compare. I'm not going to give everybody calculators, so I'm just going to use mine, and I will give you guys the answer. So in this case, we've got 2970 divided by 11. It actually equals out to 270. Is that close to the 300? Yep. Yeah. So what can we say? They have the same place value. And really with estimating, that's about all we're looking at, is do we have kind of the same number of digits? Are they at least semi-close? A good estimate is going to be within about 20%. This was actually within 10%, so that was actually a really good estimate. Okay? Now, one thing you'll notice, and your estimates will be better, we rounded down on the first number, but then we rounded up on the second one, right? Normally, as long as they're close, if you'll do opposite, your estimates are going to be better. That's going to get really important as we do those numbers 3 to 7. The ones in the middle, you really kind of need to do both ways. Oh, that's cool. You guys probably all do this, but if I take my calculator and do it sideways, I get a whole lot more options. I didn't until I just saw that. I was like, wait, that's pretty cool. Okay, next one. I'm going to start with our 12. So what do you think we should probably round that one to? 10? So with a 10, I can basically do anything I want to. Since I went down on this estimate, I'm going to go up on this one. So I up from 47, what's going to be an easy one digit? 5,000. Okay? So 5,000 divided by 10. Again, I got 1 0 that's going off. So that's going to be about 500. So the calculator says 4752 divided by 12 gives us 396. Is that fairly close? But for an estimate, that's actually not bad. Again, what are we looking at? Within 20%, just outside that 20%, but that's still a pretty decent estimate. So we can say they have the same place value. You're thinking they can do what?
Number that you still really do need to divide by 10, like 1,560.
You could, but again, we're really going super fast on these types of estimates, single digit. When it's a 10, you're right, we can basically do anything. But as we get into bigger numbers where it's 20, 40, or hundreds, then we just want you used to doing just the one digit. Okay, for our number 3, 19 is going to round. Yes, Bella? No, you don't have to, but for today, we want you trying to get down to 1 to 2 digits. And again, this is where you'll start seeing the difference. So 19, I would round to 20. Okay. So now I'm looking at 11,647. What should I round that one to?
11,500 or just 11,000?
Again, looking at 1 to 2 digits.
11,000. 10,000?
That's probably a little too much.
11,000.
Because this is so much closer to 12, I'd probably go 12. You can do 11, but does 11 divide easily by 2? Not real easily. So 12 is just going to work better. Because again, now I can take out that 0, right? 2 goes into 12, 6. That's going to be around 600. So the calculator, that ends up being 11,647 divided by 19, 613. Now there we were super close. That was actually almost within 2%. Wait, what? So what can we say about this one? They have the same place value. So that's kind of the Engage New York answer. Now they judge it to be accurate or not. As long as you're ending up around the same place value, you should be good. I prefer to think more like 20%. You guys kind of see what we're doing? Good. So I'm going to give you a chance to demonstrate. Go ahead and do page 52 on your own. Guys, remember, the whole idea on this is to make the math easy. Once I find what I'm dividing by, I'm going to get something close, and everything else becomes zeros. So in this one, 18 is going to become 20. So I now look at the other number, and I say it's at 40,644. So I'm going to focus in on the first two and figure something that's going to be easy to divide by 2. So what would I go to?
40,000.
40,000. Everything else becomes zeros. Divided by 20, that 0 goes away, 2 and 2, so that's going to be about 2,000. Make the math easy, guys. Everything else goes away. We're just going with what we have left at the very end. Okay? Our actual answer, 40,644 divided by 18 gives us 2,258. Is that close? Yeah, they definitely have the same place value. They both go to the thousands. Okay? Our next one, again, second number comes first. So 15, I can easily round to 20. So I look at my first two digits, 49, I could round to 50. So I make that 50, and again, everything else becomes zeros. So divide by 10, that goes off. 2 goes into 50, 25. So that gives me 2 zeros after, so 2,500. Now, 15 is dead in the middle, right?
Yeah.
So just to make sure everybody understands, our normal rule is 0 to 4, we round down. 5 to 9, we round up. Because 5 is dead in the middle, and we're just estimating, you kind of have some flexibility. I could have taken that down to 10. Okay? If I took that down to 10, then I just have 50,000 divided by 10. So that's just going to be 5,000. So I know my answer's probably somewhere in that range of 2,500 to 5,000. If I look on the calculator and actually do the math, 49170 divided by 15 gives me 3,278. Really is dead in the middle. I mean, 3,250 would be dead in the middle, so I'm like very close. Now here's another one that can help you guys. Normally, when I round one side up, I round the other side down. Is what you want to try to do in most cases. That's going to be really important in those ranges from 3 to 7, which are kind of those middle numbers. Those you really want to try to do the one up, one down. 1 and 2, 7, 8 and 9, it's not as important because I'm not doing a huge rounding in those cases. So they're just doing your normal rounding rules to both would be good. Okay, this one's a little different because we have a little bit smaller number, but a little bigger number. 27 is going to round to 30. So 918 I would round to 900. Again, the 0 goes away. Gives me a 3 with 1 0, so it should be around 30. Using the calculator to check, 918 divided by 27 gives me 34. So were we close? We're really close on that one, right? Does the estimating make sense, guys? Okay? It is honestly a good life skill to have. So as much as I personally don't really like estimating, it does have its place and its purpose. Go ahead and turn to the next page. This is your first page of homework. No. Just a quick hint for you. Numbers 3 through 8 I would do the opposite. So this one, 13 is going to round down. I'd round this one up. So that's going to go down to 10. I'd take that up to 10 as well. This one, again, going to go down. I'd go up. This one, I'm going to go up. So I'm going to go down. Up, I'm going to go down. Up, I'm going to go down. Okay? That's going to give you a more accurate answer. 15, because it's kind of dead in the middle, you really kind of have your choice. So whichever way you go, make sure you do the opposite on the first piece. You don't have to check it or anything else. Don't worry about checking with the calculator. If you want to, that's fine. But really, we just want to see your estimation work. So this should be a very quick page for you. Any questions on this page of your homework? Okay? Good. Let's go ahead and go on then.
I noticed something on the first page of homework.
Page 55. What's that?
It says 11, or the divisors are 11, 12, 13,
Yep.
14.
So half of them are doing 10s, which should be super easy. Okay, our first one, we're going to get back to what we just did with our estimating. I have 19 as my divisor, so I should probably round that to 20. What's going to be close to 70 that I can divide easily by 2?
You can just do 70.
I can just do 70, right? So I can just do 70,000 divided by 20. 0 goes away. 2 is going to go into 70 35 times. So I have 35 with 2 zeros left. So it should be somewhere around 3,500. Now here's what we're going to do a little different. Now instead of using a calculator to check, we're going to use what we call the division algorithm. The division algorithm, literally guys, is nothing more than a cheat sheet. But it's one that you build yourself. What are the factors that I look at when I'm doing a division problem? What's the largest number I can divide by? So let's take our example we've got going right here. I've got 70,072 divided by 19. What's the biggest digit I'm going to put up here as I'm doing each individual fact? Lydia?
10,000?
No?
I'm confused as to what you're asking.
So when I'm dividing 19, am I going to just start off with 186?
What's the largest number you
What's the largest number I'm going to put for my first one?
Okay, I see.
Will I put a number bigger than 10?
No.
No. I won't, right? So really what I want is my digits from 1 to 9 to figure out what is going to go into this. Okay? And what is my divisor? 19. So what I'm going to do is set up a table with the multiples of 19. Now, we've done tables already, right? We talked about the additive value of tables. So all I'm doing now is adding 19 to each line. So 19 and 19 is going to give me 38. I'm going to take my 38, I'm going to add 19. So 9 plus 8 is 17. 3 and 1 is 4, plus the 1 I carried over is 5. Now from the 57, I'm going to add 19. So 9 plus 7 is 16. Carry the 1. 5 and 1 is 6, plus 1 is 7. 9 plus 6 is 15. 7 and 1 is 8, plus 1 is 9. 9 and 5 is 14. 1 and 9 is 100, plus the 1, 114. 9 and 4, 13. 1 and 1 is 2, plus the 1 gives me 3. 9 and 3 is 12. 1 and 3 is 4, plus the 1 gives me 5. 9 and 2 is 11. 1 and 5 is 6, plus the 1 is a 7. 171. Is that table easy to build? Should be. I mean, literally all you're doing is adding the numbers, right? So once I've done this, now look what I've done. I now have a cheat sheet. Will 19 go into 7?
No.
No. So I skip that. We'll go into 70.
3 times.
3 times, right? Because I can look at my table. 76 is too big. So it'll go 3 times. So I subtract the 57 Can't do 0 minus 7, so I got to borrow. That gives me a 3, a 1. Bring down the next number, which is a 0. How many times will it go to 130? 6. That gives me 114. Again, won't go into 0, so 6, 1. The 7 comes down. 167, it will go 8 times. Subtract 152. Gives me a 5, a 1, and then the 2 comes down. 152, we just did that. And I come to 0. Quick hit on all today's works. If you don't get to 0, you made a mistake, probably in your table. So, with this cheat sheet, or factor table, was this hard? It's actually really easy, isn't it? So let's look at this. Did it take long to build the table? No. Did the table make it a lot easier to do the math? Yes. So is it worth investing a little bit of time to make life easy on yourself? I think so. Okay? I'll be honest, guys. The first year when I taught this 4 years ago, I looked at this homework for this problem, this page, and I'm like, oh my word, they're asking my 6th graders to do this without a calculator? And I was really worried. But then once I started teaching it and understood how easy this makes it, I'm like, yeah, actually this is a good deal. Okay, let's turn our page. Don't worry about C, we just did that. I just did it on the same page to make it easy for you, rather than having to flip back and forth for the factors. So we'll do one more together. Here we've got 315. That's going to round to what?
300.
300. Again, start on the divisor, because once I've got that one, it's going to tell me what I need to go on my other one to make our math easier. So 14,000. What am I going to do that's close to the 14? It's going to be easily divisible by 3.
15,000.
15. So once I've done the first, all the rest of the numbers just become zeros, guys. So 15,000 divided by 300. So I can take 2 off of the top and the bottom, so divide them both by 100. 3 goes into 15 5 times. I had 1 0 left over, so I know my answer is going to be somewhere around 50. Make sense? Okay? Now we build our table. Okay, we're going 1 through 9. But this time our divisor has changed. We're now looking at 315. It looks like a big number, but is it hard to add 315 to itself? Not really. Okay, so I just add it to itself. I get 630. Now I'm doing is adding the 315 to each individual line. So 5 and 0 is 5, 1 and 3 is 4, 3 and 6 is 9. Go back, 5 and 5 is 10, 4 and 1 is 5, plus that 1 I carried is 6, 9 and 3 is 12. 5 and 0 is 5, 6 and 1 is 7, 2 and 3 is 5, bring the 1 down, 5 and 5 is 10, 7 and 1 is 8, plus the 1 is a 9, 5 and 3 is 8, bring down the 1. 5 and 0 is 5, 9 and 1 is 10, 8 and 3 is 11, plus the 1 is a 12. Carry the 1 over, gives me a 2. Five and 5 is 10. It did change it that fast. There we go. 10, 1 plus the 1 is a 2. 3 and 2 is 5. And bring down the 2. 5 and 0 is 5. 2 and 1 is 3. 5 and 3 is 8. And 2. So I probably go a little quicker on the table than some of you guys can. But really, it's not a super hard one to deal, right? Now that I've got my table, I go back to my basic problem. 14,175 divided by 315. And just go straight on across and start checking. Will 315 go into 1? No. 14? No. 1,141? Nope. 1,417? Yes. How many times? 4 without going over. Then I subtract 1260. Gives us a 7. 311 is a 5. 3 minus 1 is 1. Bring down the 5. 1575, it'll go 5 times exactly. So, is 45 relatively close to 50?
It's exactly 10%.
Exactly 10% away. So that was actually a very good estimate. Are there any steps here that are confusing to anybody? No? Okay, so we're going to work until lunch. We're going to let you guys do these on your own. We've got 20 minutes, so I want you to do exercises, do as many of the next 5 as you can. Then right after lunch, we'll meet back up and go over the ones that we've done. We need to get towards the end, so we're going to go ahead and go through the problems. Our first one, and I'm seeing a lot of you still struggling on this estimating. So let's go through this step by step again. Our first step is we want to look at our second number to figure out what we're going to change it to in order to be able to make it easy. So 78 is going to round to 80. Once I understand what I'm rounding to, now I'm going to look at this number and I'm going to say, okay, I've got basically 48 is really what I'm focused in on. And I need to get a factor that's going to be really close that I can get 8 to easily. 48.
Yeah.
8 goes into 48. So in this case, whatever that first number is, the first 1 to 2 digits, everything else becomes a 0. Divided by the 80. 0 goes away. 8 goes into 48 6 times. So I have a 6 with 4 zeros. 1, 2, 3 zeros. So it's going to be somewhere in the neighborhood of 6,000. Okay? Estimation, guys, literally should only take you that long. I mean, I've got people on my side that are still doing the estimation on problem 1 at this point, after 25 minutes. It should literally take you seconds. The whole idea behind estimation is we're making the math easy for ourselves so you can do mental math. You can change the numbers however you want. That's the whole idea of estimation. Just make sure you do it quickly, because that's what we're trying to do. Once I've done that, now to do the actual math, now is where I need to build my table. So we're going 1 through 9. I start with my first factor, 78. Literally, guys, all I'm doing is adding the 78 every time. So adding it to itself is easy. I have a 6, then 15. 8 and 6 is 14. 12 and 1 is 3. 8 and 4 is 12. 7 and 3 is 10. 8 and 2 is 10. 7 and 1 is 8, plus the 1 is a 9. 8 and 0, 8. 7 and 9, 16. 8 and 8, 16. 13 plus the 1 is 14. 8 and 6 is 14. 11, 12. And 12, 9, 10, 802. Once you've got your factors all set up, now I actually do the math. 692, and I'm dividing it by the 78. And I'll do it Miss McShan way. So will 78 go into 0 or into 4? No, so 0 goes over it. We'll go into 48. No, so 0 will go into 484. So I go as close as I can without going over, which gives me a 6, 468. So Subtract 468. Gives me a 6, a 1. The next 6 comes down, goes into 166. Twice. Gives me 156. So now I've got 10. Bring down the next number, which I'm at the 9. Goes into 109. Once.
Your 9 is incorrect. It should be 702. No, I'm saying on the chart. It should be 702.
Oh, you're right. I knew I didn't use it, so I was just going fast. 78 gets me 31. 312 is 4. So what is it? 6,214. Is that reasonable given my estimate?
Yep.
And that's really a good thing on the estimate, guys. It's basically a quick check for yourselves. Okay? Our next one. Again, start with your divisor. 33 is going to round to 30. So now I'm going to get a number close to 28 that I can do by 3. 30. So when I make that a 30, all the rest of the numbers become zeros. So I've got 300,000 divided by 30. The zeros go away. 3 goes into 3 once. So I have a 1 with 4 zeros. So it's probably going to be somewhere around 10,000. Make sense? Okay, for my actual table. Start at 33, 99, 12, 12, 13, 5, 6, 8, 9, 11, 12, 13. I did it again. 4, 6, 7. Okay, so the factors. And again, although I realize you guys are probably not going to be able to fill out your table quite as fast, it still shouldn't take you that long. Remember, it always comes back to I'm adding in whatever that first value is to each line as I'm going. But now that I've got that table, so I've got 281,886 divided by 33. Will 33 go into 2? No. Will it go into 28? No. 281? Yep. 8 times. So subtract the 264. So borrow gives me a 7. 1. Bring down the next number is an 8. 178. It will go 5 times. Subtract 165. Gets me 3. 138. It's going to go 4 times. Minus 132. I got close. Then 66. It's going to go twice. So my answer was 8,542. Does that seem reasonable given my estimate of 10,000? Yeah, it's a little bit off, but again, I did some pretty big rounding. Once you're getting in the middle numbers, you're rounding so much that your estimate is going to be off a little bit more. Okay? Going to our next page. Again, start with our divisor, 37, I'm going to round to 40. So I want another there, 22, that's going to be good with 40, with 4. Okay, one big one. I rounded up here, so I'm better rounding down if I have an option here. 20. Okay? So again, all the rest of the numbers become zeros. So that's going to be coming straight up 2 million. Divided by 40. The 0 goes away. 4 goes into 20 5 times. So I ended up with 4 other zeros that are not being used yet. So I'm looking at an answer somewhere in the 50,000 neighborhood, right? Building my table. On 37, becomes 74, 11, 8, 4, 15, 7, 8, 12, 11, 12, 9, 5, 16, 8, 9, and 333.
Okay, I discovered a trick to make filling out the table faster. Mr. Parkinson needs to do like that.
I'm literally in the middle of taping.
Okay, yeah, come later. Okay, sorry. Like 6 minutes to do that. Okay, sorry.
Okay, so I have 2,295,517 divided by 37. Will 37 go into 2?
No.
22?
No.
229?
Yes.
Yes, how many?
6.
6. Subtract 222. Gives us a 7. Goes into 75.
2.
2. Minus 70, or 74 gives us a 1. Goes into 15.
No.
Won't, so I put a 0. So I bring down my next number, 151.
Yes.
How many?
4.
4. So that becomes 148. And 3, bring down the 7. It's going to go once. So we ended up with 62,041. Is that within the realm of my estimate? Yes, sir.
I figured out an easier way to fill out the table.
How's that?
So what you can do is, if you're having like trouble on one of them, say if you're having trouble on finding out what the 5th one is, you just add 2 or the 2nd one and the 3rd one.
Yeah,
And then you get it for.
Yeah, you can do that. I just think it's easiest just to take this and add it to the one right above it. But that does work as well, because the 2 and the 3 is the same as the 1 and the 4. If you want to find 5. Okay? Any questions on that page? Okay, so unfortunately we've only got a couple minutes left, so I'm going to go to the last page. Here is your homework. You'll note, got a lot of problems there, right? So doing that table for every single one of those would be a little bit, right? So instead, all you have to do is these bottom 4. Okay?
No.
Don't have to do the estimate. And just as a side note, on page 54, it says check your answer, your estimates with the calculator. You don't have to do that part either. Really just, we want you on page 54. All you got to do is the estimates, guys. Page 56, all you have to do is the algorithm for these 4. But that being said, we expect to see your table is your work on this, and then show us the long division. We cut it down to 4 because we do want you to do that. You don't have to check with the calculator. If you want to check your answers here with the calculator to make sure you did it right, I don't have a problem with that. But make sure that you've done all of the work. Show us the table and make sure everything is laid out for us. Any questions on this? You're doing 2 things. Page 54, you're estimating. Page 60, you're just doing the division. You do not have to estimate on this page. Andrew?
On page 54, do we have to find those quotients?
Yes.
Use that quotient?
The estimated one.
The estimate. You don't have to check with the calculator, no.
Oh, so you don't have to do these steps.
Correct.
You don't have to do regular division, no.
Okay.
Estimate and you do estimate.